Hello everyone, welcome to Focal Point. We are going to start scoping concept of variables in C programming language. So this concept is really very important because without knowing this concept, we will not be able to solve question asked in competitive examinations. And so we need to have an idea about what is the difference between local variables, local static variables, global variables, and dynamic allocated variables. Okay, so these are all concepts we will be discussing on this video. So let's start. I have taken this example. This is a very basic example. I will explain you how to get the answer of it by using our scoping concepts of the variable, and after that we will run the program and we'll see that our output matches or not. Okay, so now we have to see how many types of memories are there in which our variables are stored. Okay, so for that we need to see. So we have different memory locations to store different variables. Okay, so how many types of memory is there? We have static area, we have stack area, and this is heap area. Okay, so what is stored inside this static area? So our local static variables and the global variables are stored inside this static area. Okay, so our local static variable and the global variables are stored inside this static area, and our local variables are stored in this stack area. Okay, and our dynamically allocated variables are stored inside this heap area. Okay, so our local static variables and the global variables are stored inside this static area. Our local variables are stored inside this stack area and dynamically allocated area. That for that we are using malloc and calloc concept. Okay, so this concept will be used in the structure chapter. Okay, so we will see in that chapter. And global variables are allocated memory by the compilers in the static area, and dynamic variables are allocated memory by the processor at the heap area. Okay, these are the three memory locations where our variables are stored. And now we have these two concepts of scoping in which our compiler is gonna work. So first is static scoping and second is dynamic scoping. So what is the definition of it and what is the meaning of this? Static scoping is also called lexical scoping. In this scoping, a variable always refers to its top level environment, and in the dynamic scoping, with this dynamic scope, a global identifier refers to the identifier associated with the most recent environment and is uncommon in the modern language. Okay, so this is the formal meaning of it. I will be explaining what is the practical meaning of this. Okay, and I want to tell you that static scoping is the important thing because this is the scoping that is being used by most of the programming languages of modern time, and this dynamic scoping is not being used by the most of the programming languages. Why is that? I will be explaining that. Okay, so this is uncommon in the modern languages. So what is the practical meaning of this static scoping and the dynamic scoping? I will be explaining in here. So I have assumed that this is our stack area and this is our static area. Okay, so what is the meaning of static scoping? So when we are calling our main function in here, and after that we have called some a b c d functions in here. Okay, and some variables are defined in here as well. Okay, a variable defined in here a b. So what happens if I have called this d or c or b or a and working on our stack area? If any variable is not found, okay, if any variable is not found, what will be happening? If variable is not found in the local stack area in the local function, so what it will be doing, it will go and search inside the stack area. Okay, I am talking about this static scoping. Okay, so in the static scoping, whenever a variable is not found inside the local function, then it will go and search inside the static area, that is in the global variable or local static variable. Okay, if the local variable is not found in this stack area, then it will go and search inside the global variable or static variable, that is in the static area. Okay, so if variable is not found in the stack area, is directly go and check inside the static area. This is the concept of static scoping, and this is the scoping is being used by most of the programming language. Okay, so this is the concept of static scoping. Now let's see what happens in the dynamic scoping. So let's see what happens in the dynamic scoping. So in the dynamic scoping, if this variable is not found inside the local function, let's say assume that we are calling this main a b c d functions, and if our local variable is not found in here in the d function, so compiler will pop this function out and go inside the C and check for the local variables of same type. Let's see, a is not found in here, so it will search inside this for the a. Okay, so if that variable is not found again, so again this will pop that out and check inside the b. And if this variable is not found in here as well, then this will pop that out and check inside the local function a. If that variable is not found inside this a, then this will pop out this function and check inside this main function. And if it is not found in here as well, then it will pop it out and then it will check inside the static area. Okay, so you have got that. It will not go and check inside the static area directly, but it will check, or it will refer to the most recent environment. Okay, so most recent called function will be checked. Okay, so we will check inside the most recently called function, and we will try to find that out. If that variable is not found, we will pop that out and check inside the next most recent called function, and we will keep on doing that. And after that, at the end, we will check inside the static area for in the global variables. Okay, so this is the process of dynamic scoping. In the static scoping, if our variable is not found inside the local function, then it will directly go and check inside the static area. Okay, but in the dynamic scoping, we are not going directly to the static area, but we are going to pop the current function, and after that we are going to check our most recent called function. Okay, if that is not found in that function as well, we are keep on doing that process, and at the last we are going to check in our static area. Okay, so this is the concept of dynamic scoping. Okay, so this is the concept of static scoping and dynamic scoping. So let's see what is happening in this code. Okay, so this is our code in here. I've called, so I'm going to execute this code line by line so that we can use our all these concepts. So we will execute this code by using static scoping concept, because our C compiler is using static scoping concept. Okay, we will also check that if our answer is coming with the help of static scoping and our compiler also support that answer or not. Okay, so this is our C program that I have taken in here, and we will execute line by line. So what I have included in here, I've included our standard input output header file, and these are three functions that I have called in here, and this is our global variable. Okay, all the variable outside will be global variables, and the variable defined inside the function will be considered as the local variable. Okay, and if we are using a specifically static keyword, then that local variable will be considered the local static variable. Okay, so I have already told you that the local static variable and the global variable will be stored inside the static area, and the local variable will be stored in the stack area. Okay, so let's see our program in here. So I have taken our stack area in here, and this is our static area. Okay, so in the static area, what I'm going to do, this is our integer a, that is a global variable. So I have defined and initialized with 5 in here. Okay, that is in the static area. If we are defining our global a inside this static area and initialized with 5. Okay, and now what I'm going to do, I'm going to call our main function. So main function will be called inside this stack area, and what I'm going to do now, I'm going to take again integer a, but this is integer a is a local variable now. Okay, so that will be defined in the stack area inside the main function and initialized with number 10 in here. Okay, and now what I'm going to do, I'm going to call our function b in here. Okay, so our b function will be called inside this stack area. Okay, so let's see what is the definition of this function b. Again, I'm going to define an integer a in here, that is a local variable, and initialized with number 20. and after that again I am going to call function c in here. So I will be calling our function c inside this stack area, and let's see what is the definition of this c. Again we are going to define an initialized variable integer a, and initialized with 13 here, and we are going to call our function d. Okay, so this is our function d. So what is the definition of this d? We have again defined our integer a, that is a local variable, and initialized with 40. So what is the meaning of all these? So these all a variables are local variables of respective functions. Okay, this is a local variable for main function, this is a local variable for b function, this is a local variable of c, and this is for d, and this is a global integer a, this is a global variable. Okay, so what I'm going to do in here, I am going to print the integer a in the d function. In the local function d, I am going to print the value of a. So what will be printed in here? So I've already told you, based on the static scoping concept, if our variable a is defined and initialized in the local variable in the local function, then that value will be printed. Okay, so in here our complete definition of this integer a is given, and this value is initialized with 40. Okay, so based on the static scoping concept, this complete def information is present in the function itself. Okay, so we will not go inside the static area. Why? Because the complete information is present. Okay, so what will be printed in here? So finally printed output will be 14 here. Okay, so let's see what is the answer of it. So we are going to run our code in here, and one important thing that we don't need to have any id for the C programming language for basic thing. So for the basic C programming, we don't need any id for that. We just need to download notepad++ and a GCC compiler, that's it. We don't need anything else. Okay, so we have compiled the code, and let's run the code, and you can see that the answer is 14 here. Okay, so so why is that? Because our a variable is already defined and initialized in the local function d, and that's why we are not referring to the static area. Okay, so if this variable is not defined in here, so what will be happening? Okay, so for that I've told you that if this variable is not defined in here, and I'm just directly going to print this variable a, so what will be happening? So I've told you that this will directly go and check inside the static area in the global variables and see about this variable a. So this variable a is defined and initialized in here, and that's why now when we are going to run this code, then our 5 will be printed. Okay, so let's run the code again and check our answer is 5 or not. Okay, so you can see that now the answer is 5. So why is that? Because this variable is not defined in here in the local function, and based on the concept of static scoping, this is directly going to check inside the static area in the global variables. Okay, and so we can also know that our GCC compiler is working on the concept of static scoping. So I've told you that I will be telling why most of the programming languages are using static scoping and not using the dynamic scoping, because this is a local function and this is another local function, and in the dynamic scoping this will pop this function d and check inside this c. Okay, but this is a local variable, and we are not allowed to access, and any local function is not allowed to access the variables of some another local function. This is the security breach. Okay, so because of this security problem of local variables, our dynamic scoping concept is not being used by the most of the programming languages. So this is the reason why dynamic scoping is not being used by the modern languages, and scoping and static scoping is being used. Okay, so you might have got the idea of static scoping now. So if our variable is defined in here, so this variable will be here. So we will not go and check inside the static area. If variable is not found in the local function, then it will directly go and check inside the static area for the global variable. Okay, so this is the concept of static scoping. So in the next video I will tell you if this variable is just defined and not initialized, okay, so what will be the answer of it, and if it is a static local static variable, and then in that case what will be the output of it. Okay, so this will I will tell you in the next video. Thank you so much.